Each year, millions of gallons of hazardous waste fluid generated by the petroleum processing, chemical, pharmaceutical, and other industries are disposed of deep underground through injection wells. These injection wells are called Class 1 hazardous waste disposal wells. To make sure these injection practices don't harm people or the environment, the Underground Injection Control Program requires multiple layers of protection through stringent regulations. This animation shows how the siting and construction of a typical hazardous waste disposal well provide that protection. Geologic investigations are conducted to make sure injection wells are sited in areas that allow for the long-term subsurface containment and isolation of injected waste fluids. Seismic evaluations are conducted to make sure the area is stable and has suitable geology. In addition, the area of review, an area with a minimum 2-mile radius around the injection well, is checked for artificial penetrations, such as open or improperly plugged old abandoned wells. If found, these potential pathways are sealed to prevent movement of injected fluids. Most of the well is below ground level. Waste fluids are disposed into rock formations called the injection zone. These rock formations have interconnected pore spaces that readily receive and hold fluids. Above the injection zone are multiple confining layers of rock with low permeability to prevent fluids from moving out of the injection zone. Hazardous waste wells inject fluids from 1/2 mile to over 2 miles below the ground surface. Injecting to this depth isolates the fluid from underground sources of drinking water, which are generally shallow groundwaters that are used or could be used as sources of drinking water. The injection well's first layer of protection is the surface casing and cement. First, a borehole is drilled to a level below all underground sources of drinking water. A steel pipe or surface casing is then installed from the surface to the bottom of the borehole. Cement is placed to seal the space between the surface casing and the rock. Sealing this space isolates the well from underground sources of drinking water. A second layer of protection is provided by the long string casing and cement. A slightly smaller borehole is drilled from the bottom of the surface casing borehole to the injection zone. The long string casing is installed from the surface to the bottom of the borehole. Cement seals the space between the long string casing and the rock from the bottom of the well to the surface. Sealing this space with cement prevents the injected fluids from moving along the borehole and out of the injection zone. The long string casing and cement are usually perforated at the bottom so injected fluids can move from the well into the injection zone. A third layer of protection is provided by tubing and a packer. Tubing is installed inside the long string casing with a small mechanical device called a packer at the bottom. The tubing material and the packer are resistant to chemical reaction or corrosion from the injected fluids. The packer seals the outside of the tubing to the inside of the long string casing. The top of the well casing is fitted with a wellhead that controls the flow of fluids and can tolerate high pressures. The space between the tubing and the long string casing from the wellhead to just above the packer is called the annulus. The annulus is a watertight space filled with a non-corrosive fluid that protects the casing and tubing from damage due to chemical reactions. Once the injection well is inspected and approved for use, injection can begin. Waste fluid moves from the facility through a pipeline into the wellhead, down the tubing, and into the injection zone. Continuous monitoring and periodic tests are then conducted to ensure the well is operating properly. As you have just seen, a properly sited and constructed deep injection well has multiple layers of protection to keep injected waste fluids contained in the injection zone, where they are safely isolated from people and the environment. For more information about the Underground Injection Control Program, visit our website or contact the Safe Drinking Water Hotline.